All right, greetings, YouTube. This is Beautiful Mind. So, as promised, again with another one of my classes, just time ran away. We were having so much fun in there. We didn't finish the things that we needed to in class, so that way we're not eating into the review session on Monday. We're gonna do the remaining of the lecture here on online. It'll take a few minutes; it should be less than 10 minutes. So, real quick for input output. Remember, we went through this in class. Okay, input output. I'm gonna just pick up where we left off, really. Okay, so we described how to fill in the input output. Each column represents what it takes to produce $1 worth of the industry. So say you have a system where each industry depends on others to produce goods. So to produce $1 worth of coal, it takes, let's do this, like this. So to produce $1 worth of coal, it takes 0 coal, 2 cents of steel, and 1 cent of electricity. For $1 to produce $1 of steel, it takes 15 cents of coal, 3 cents of steel, 8 cents, so on and so on. So that's what this paragraph is saying. And that's how you fill in it. Each column represents $1. And then we want to find the production level to meet this demand. So 2 billion of coal, 1 billion of steel, and 3 billion of electricity. Okay. So this is where we left off in class right here. Okay. So then what I was trying to remember was the way it's generated. So then, what's our variable matrix? What is that going to tell us? Oh, so we're having a discussion on how much of each one should we produce. So then if we consider, this is background information, and you don't need to know this now as my students. You don't need to know this. You just need to know how to use this. I'll give you this formula, and we'll go from there. But I'm gonna give you a background on where it comes from. So say we want to produce X amount, and what this is referring to is like we have our X, Y, and Z. So this is like how much coal. This could be like coal here. This would be steel, and whatever the third one is, electricity. How much of each one to produce, okay? So this is variable matrix X. So if we produce X amount, right, minus, how much we use in production, because, the whole point of the input output is, you use some of this stuff to produce itself. So we want to produce X amount, but then minus whatever's used up in production, and then to meet whatever the demand is. Okay, so then if we use our matrix operations to solve for X, we can factor out the X in the following way. We can say I minus A times X equals D. Now notice I kept the X on the right, because if I were to distribute, I would keep the X on the right hand side, because the order of multiplication is important in matrices. So that's why I moved it to the right. So then if I have this and I want to solve for X, then what I would do, I want to left multiply both sides by the inverse of this first matrix. So I'm going to say the I minus A inverse on both sides, on the left side of both sides of the equation. I minus A inverse. So that's, my teachers in grad school call that left multiply by the inverse, okay? Because again, the order is important. So now if we have a matrix times its inverse, then what we're going to get here is I times X equals I minus A inverse times D, and then the identity times the matrix is itself, so then X is going to be I minus A inverse times D. Let me make sure that's correct. I think that is correct. So then, now this is the input-output formula that we use for this topic. Again, you don't need to know this. I'll give you this on the exam, so you just need to know how to use it. So then, doing this operation, solving this matrix equation should give us the solution that we're looking for. How much of each industry we need to produce to meet the demands. So then the I in this case is a 3x3 identity, okay? So then we have 1, 0, 0, 0, 1, 0, 0, 0, 1. Minus the coefficient matrix, which is, or the input-output matrix, which is here. So I'm just going to copy this, and I'm going to paste it here. Let me shrink that guy down to size. Okay, this is fine. So that's the I minus A in parentheses. Then I want to take the inverse of that and then multiply that by our demand matrix, which is 2, 1, 3. 2, 1, 3. Okay. So then we're going to go like this. So then our x should be equal to that. Okay. So then if we do this operation now, I'm going to leave it. Actually, I'm going to leave this as an exercise for you. So I don't want to eat up too much time actually doing this operation. I just want you to know how to do it. So, you can say the first matrix minus the second. Now, remember in class, we said in order to add and subtract matrices, they have to be the same size. Note that the size of the first matrix is 3 by 3. The size of the second is 3 by 3. So when we add them, in this fashion, we're going to finish with the 3 by 3. So then we're going to finish with the 3 by 3. Then we're going to say times. Notice this is a 3 by 1. So we'll say times column matrix 3 by 1. Notice that the 2 in the middle match, so we'll finish with the 3 by 1, and that'll be our solution, okay? So then I'm just going to do this in the calculator, and actually on the exam, I don't mind if you put this whole thing in the calculator. I just want you to know how to use this, okay? It's not realistic to do this by Gauss-Jordan or anything like that, not for this, because it gets kind of dicey. So let's see it in the calculator. So then what I'm going to do in my calculator, I'm going to go to my matrix, right? I'm going to go to edit for my matrix A, which is a 3 by 3. My 3 by 3, I have 0, 15 cents. I have 43 cents. Now, this is probably the hardest part, is typing in the calculator for this. Because if you make a mistake, or if you don't have a graphing calculator, that can get kind of dicey too. So then you have to do the best you can. I almost made a mistake right there. 0.2, 0.1, 8 cents, and 5 cents. Okay, so let me look at it one more time. 15, 43, 02, 03, 20, that's fine. 01, 08, 05, okay. So then what I'm going to do, I'm going to quit, clear, whatever. So then I'm going to call up the identity. So first I'm going to say parentheses. I want to go to matrix, math here. There it is, number 5. I want a 3 by 3, so I hit identity 3. That means a 3 by 3 identity. I want to say minus our matrix A that we just typed in, close parentheses. Then I want to say just hit the -1, so that means inverse. And then I need the matrix B. So I'm going to go to matrix, edit. This is a 3 by 1. This is 2, 1, 3. I want to quit. I'm going to say times the matrix B. Okay, cross our fingers. And I think this is a reasonable result. I can check my notes really quickly. So we're saying that X is approximately, how much of each to meet the demand? This is billion. So 3.7 billion, let me see, 1.8 and 3.3. Let me just check my notes. And again, this is the coal, this is the steel, and this is the electricity. It should be electricity. This should be in billions. Let me check my notes to make sure that these numbers are correct. Oh shoot, it's not there. That's right. How can I check this? Is this for mine? I think this is mine. Sorry about eating up the time. Okay. This is 2, 6. I think this is the same as mine. Let me see. Nope, it's not the same. 1543. Maybe it is. 203. Let me see. It's looking like it is. 203, 20, 01, 08, and 05. I minus A inverse times D. The demand matrix. I minus A inverse. And I don't think that's what I got. 3.7. Oh, 4, 1.5. Oh, okay. Let's see. Yeah, that's a different demand matrix. That's why this is different. Okay, well, I'm going to have to, and this is in billions, so I'm going to have to go with this result because I don't have the solution. So I'm going to have to stand by it, and this is in billions of each. Okay, so with that, we will end the session there, and from one beautiful mind to another, enjoy the rest of your weekend. And just hit the, yeah, everybody's gonna hear it, that's fine. But yeah, so be sure to like, share, and subscribe. And that's it, yeah. Have a good weekend, gentlemen.